Hello, my name is Steve. What I've promised in my previous video is that I would go through the repair on my Dressler D-200S amplifier. This amplifier operates on 2 meters VHF and is good for about 700 watts out, so they say. It operates through a 4CX350 alpha tube, and all the power supplies and everything else is integral in the case. As you can see from the front panel there, it's in pretty good condition. I picked this up as not working on eBay, and I set out to repair the amplifier, for which I discovered a few faults. I'll run through the repair and what I did, and then we'll go and test it. Now, the amplifier hasn't been tested yet. I've changed some components, I've repaired some tracks on the PCB board, of which a number of tracks were burnt out and broken. I've replaced the filter capacitors and the balancing resistors, and the high voltage rectifier was blown as well. So I replaced all of that, including all the associated diodes and resistors in that circuit. One of the things I did discover with this amplifier, it is very compact, but there are about 10 potentiometers inside which are preset. I have no idea how I'm going to set those. I'm just hoping that somebody hasn't been in there and adjusted them all beyond reasonable settings. Unless I get a service manual, which I'm still looking for, and if anyone has one, I'd be very keen to get one or a copy. So then I could make those kind of adjustments. However, I'm going to give it a test run and just see how good it runs. What I'll do is I'll just disconnect this from the camera from the tripod, and we'll run through the circuit as to what was replaced. Just down the bottom here, I'll just use a Sharpie here. You see a lot of fairly close tracks. Those tracks carry the mains input voltage through to the front panel switch and back again, and operates a number of relays in the back. These relays are to switch the main voltage, input voltage, in to all the rest of the circuits, and the second relay operates off a timer to turn on the high voltage once the valve's warmed up. There is a timer circuit on the control board. Down the back there, starting from the very back, there's the output. There's 2 coaxial relays. This little variable capacitor here is a part of an attenuator circuit, which is switched out of line if you want really high power, but that must be only used for very short periods of time. Then this amplifier is supposed to go above 700 watts, but based on the age of the amplifier, I don't think I'll be operating it at that speed. At the back here, there are 2 inputs here. One's PTT, which is a ground seeking PTT, which I'm using currently, and this one is for a positive voltage to switch the amplifier if your transceiver provides a voltage to switch the PTT. This switch here is a high and low position for either going through this attenuator circuit or not, as the case may be. So in the high setting it bypasses, and in the low setting, which it is currently set at, and that's where I should be using it, it will be attenuating the signal coming in. The 4CX series tubes require just a sniff of RF to perform. Just down the back here, there's a loading capacitor, and that RFC there is for a 15 volt DC supply, which goes for a T-bias network. Moving down here, you can see some one of the filter capacitors. In fact, you see 2 of them there. They're 600 volt working at 100 microfarads, and what there's 6 of these. They also have a resistor across each one of, I think, about 750, 720 or something like that K ohms, which I've replaced because the 2-watt carbon ones that are in there previously, some of them had gone high resistance based on the age of this amplifier, and that would unbalance the voltage across each individual capacitor. So they were replaced, and these filter capacitors too. Moving forward, there's the blower. The blower intake is on the top here, as you can see, and that blows into the just come out a little bit, comes into the RF box. The RF box has a high Q inductor, which is a large plate which is isolated from the high voltage for a Teflon gasket, and the high voltage, when it gets into here, goes down for a radio frequency choke onto the anode cover. Those familiar with the 4CX series valves would be, you know, familiar with the way that the anode voltage connects to the valve through the heatsink. The exhaust is on this side, and there you can see the whole of the RF box here. Going into the RF box is the tune variable capacitor, which is this control here. The load capacitor is this one here, which goes all the way through to the load capacitor at the back. The high voltage transformer provides 1600 volts off its secondary, and it's got 2 fuses. There's a 1.6 amp fuse, which is in the power supply to the high voltage transformer, and the transformer only provides high voltage in this case. It doesn't provide any other voltages whatsoever. The output of the transformer sits through a large fuse here, which is a 800 milliamp fuse. Now, when I got this fuse was blown, and the replacements are just not obtainable anymore. They're very expensive fuses if you can get hold of them. So what I did was I manufactured two brass couplings and a microwave oven 800 milliamp fuse pressed into the center. That with a couple of layers of heat shrink over the top, so it should keep that intact if it goes. Down here you'll see some light blue resistors, and either side of them you'll see a chain of diodes. This continues to go underneath the blower assembly. That's the high voltage rectifier. There are 4 1N4007 1 amp 1000 volt PIV diodes there, and that then comes along underneath the board. A track comes underneath the board and goes through a couple of RFCs before going into the RF box. A couple of relays here for the grid voltages. Transformer here provides voltage to the grid one, which is about 100 minus 100-ish volts, and for the G2 on the valve, which is the screen voltage, at about approximately 400 volts. After it's been rectified, it goes through here and it comes out here about 400. Here are some rectifier tubes. There's 3 of them, OA2s I believe. I think they're OA2s, yep they are. And that's in the screen circuit. Moving towards the front, I had a lot of problems here. The dual inline chips had a couple of faults in. One was a timer one, another one was an inverter. I think I've got the numbers with me, I'll just have to dig them out. But after replacing a couple of these and going through the board carefully, I managed to get it going. You'll notice some tantalums in there still. I mean to replace those, but currently they're functional. Then there's the display board down the bottom here, which operates all the different measurements that's required to come out on the meters. There are 2 meters. One of these on the right is for the anode current, and the other one does all the other ones. There's grid 1, grid 2, HV voltage and power out, which is selectable on this control here. So that's it. Now I checked the amplifier just now using the light bulb method. I've got a 100 volt bulb there that I put in series with the power supply, and the whole of the amplifier switched on, albeit rather slowly at a lower voltage, and there were no shorts. So I've taken that out of circuit, and my intention now is to start testing this amplifier. On the outside of the amplifier, I'm measuring the output power. This is a wave node module. It operates between 120 to 170 megahertz, between 0 and 2000 watts. And there's the wave node control box here, which operates through my laptop. I'll just put that up on the screen. And what I'm going to be using is the ICOM input power and the Dressler 200S output power here. This measures output power as well as SWR, and in both peak and average on both, and it also measures the SWR. That there connects to this through a USB, and the little green flashing light there indicates that the USB is connected and active. On the other side, I'm using an ICOM 706 Mark II as the exciter, or the transceiver if you like, and I'll be measuring the output power through an identical unit, so that I can see what's going in and I can see what's coming out. Okay, we're just about set to switch the amplifier on. One of the things I need to be sure about is that I have set the power on the IC706 there to the lowest power setting, so as to affect the initial tune-up stages, and we'll be able to monitor the power output and the HV voltage on the small meters. I'll zoom into those once we get switched on. I'll just go back over the controls. This is the tune, and this is where we do the initial tuning, and what we do there to tune with is we ensure that we're tuning to a dip in current on the anode amperage. Now the maximum amperage is 300 milliamps with CW key down, or indeed FM or AM in a full duty cycle type modes. I believe in intermittent service you can go above that in SSB for when you're needing a lot of high power on SSP. But I'm going to be very careful, as this is an old amplifier. I don't want to put it under any stress, so I'll be being very careful to keep everything set below 300 milliamps. On switch on here, we go to standby. After 80 seconds, the 4CX tube has to heat up, and all the other voltages stabilize fairly quickly, but the heater at 6.3 volts has to give the tube time to heat up in order to function, and the timer circuit holds for about 80 seconds for that to occur, and then high voltage is switched on. We go to operate. That switches in the PTT line so that we can key the rig, and that's where we'll be initially to get the to start tuning up. What we'll do as soon as the 80-second valve warm-up time is complete, we'll just check that we have the correct voltage. It will be around about 2200 volts, I'm estimating. And then what we'll do is we'll switch across to output, and that will give the output in watts on this meter here, and we'll use that to tune. So we'll be tuning from for more power, less current. So we'll be looking for a dip in the current, and then once we've got that to as low as it can go, we then go to load to tune for the most power. Then we can come back and do tune again and load again if necessary, and then once that's happened, this amplifier is pretty much set. You don't need to adjust it for about, I think it's 30 kcs either side of I'm not too sure. I think it's 50 kcs. It's if you move more than 50 kcs in a 2 meter band, you need to retune. But that should, if I've tuned this on 144.3, then that will operate throughout the whole of the SSB portion of the 2 meter band without having to revisit tuning and loading. I'll check the grid currents here, grid 1 and grid 2, which is the screen. So we check those currents. They should be very low. Absolute maximum is 25 milliamps on the screen, but I'm hoping to be seeing a lot less than that if that tube is a good tube. Just briefly, that tube is a second-hand tube. You take your chances with these tubes. They can be unreliable when they had a lot of life service behind them. They're quite robust when they're new, but with new they're quite expensive. If this amplifier runs very well, it might warrant a new tube replacement. But until then, I just want to make sure that everything's functioning. I need to ensure that the high voltage transformer is doing what it should be doing. I don't see any fizzes or crackles in there. I want constant voltage. No, I haven't got power applied yet, but we'll be keeping our hands well away from this area here, and don't lean over with anything that's likely to fall off into the circuitry there. Okay, let's put the power on. You can see that the blower is started. The panel lights have come on, and the 3 low voltages have been supplied to the valve. That's the heater at 6.3, that's the grid 1, which is about minus 100 volts, and the screen voltage is approximately plus 400 volts. They're very low current supplies, and they're supplied by the small transformer. The small transformer also provides the power to the regulators. There's a 12 volt regulator in there, and there's a 15 volt regulator for the masthead preamp. This takes approximately 80 seconds before high voltage is applied to the anode, and we're kind of halfway there, I think. The panel lights are very low. They don't illuminate very brightly. They're 2 very small bulbs, but they're both functional, so I've left them as it is. I was considering putting bright LEDs in, but there we go. Right, we got high voltage. Now, that's the ready LED that's just come on, and if I zoom in to the meter, I'll just get it a bit accurately. It's set there. Let's just come back out so we get both meters. We can see that the high voltage, or the meter on the left, is looking at the HV voltage. So we've got HV voltage on the anode now, and we don't have any current. If there's any there, it would be so quiescent that we don't see it. So that's good. So far, so good. I'm going to key the microphone and see if we get PTT. So I'll just take the microphone here, and I'm just going to key the mic and see if we get PTT. Now we're connected to a kilowatt powered dummy load, so it's a 50 ohm load on the amplifier. Never key an amplifier without the load on there. So I'm just going to key to see if anything occurs. Of course it won't do until I go to operate on here, so that's on standby. So we're going to go to operate, which brings the PTT line in, and the red LED just here should light once the amplifier is keyed. and you'll hear the two relays at the back cross over. And there we go, the red lights come on and it goes out, and we see some current down there. It's about 50 milliamps, which is about right. Okay, I'm just going to whistle in the mic just briefly. I'm just going to change the this left hand meter now to output, so that's measuring output power. I'm just going to go, wow, that's a lot of power. I didn't expect that much to come out. I'm on the lowest setting on the transceiver, which is just a couple of watts, if anything else. I'm just looking over here. That's, if I just put you on there, the two left-hand blocks. I'll just zoom in a bit. The two left-hand blocks are the 706 transceiver, and the one under my call sign here is the Dressler 200S. So let's just have a look. I'm just keying this, and I'm getting 200 watts. I'm putting about 2 watts in. So watts forward, you can read them from here and here. 1.8 watts, and 180 watts that time. So let's just go back on here so that this amplifier is working, which is a great sign. Now I haven't adjusted the tune and load adequately yet because it must have been fairly close to where it should be, but you don't run a valve amplifier unless you're absolutely sure on getting the anode current dipped as low as you possibly can on the tune, and the output on the load is tuned to maximum. So okay, so we're going to tune for a dip. There we are, there's the dip, and load for power. And there we have it. There we go. That's all I'm going to do there. And I'm going to switch back to SSB. Okay, let me just key that, and let's have a look at the 2 meters. The left-hand meter, remember, is power out, and the right-hand meter is anode current. Go and have a look over here. And that the Dressler is putting nearly 200 watts out at a couple of watts in. Testing 1 2 3, test 1 2 3, test 1 2 3, test 1 2 3, test 1 2 3 4 5. So I need to go to another scale on here. And 15 watts on the input side. We should never get to 15 watts, but now we can see the scale because it went off the scale on the 200 scale, so which was unexpected at that low input. That's quite good. That's 200 watts, and the anode current is sitting at about 100 milliamps. Okay, so the current's nice and low. Now I'm going to also check grid 1. Now this left-hand meter is going to measure the current in grid 1. I'm hoping that there's hardly any detectable current there. That's good, there's no current detected, and we'll go to the screen. That's incredible. I expected to see some screen current. We're about 250 watts out on the other side there, so that's not bad. That's nice and low. So we're going to increase the power. Now there's the tiniest amount of screen current there. And on the output, we go to the output screen very quickly. It is looking pretty good. One, two, 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 two. Okay, we're about we're peaking at 250 there, and average is a bit lower than that, but it's we're just looking at peak to peak currently, and looking at the anode current. One. We're nice and low. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Seeing a very slight kick on the screen current. Let's go back to the grid at this higher setting. Hopefully we don't see much at all. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Test, test, test. That looks very good. In fact, I'm quite pleased with that. That's no detectable grid current, and the screen current is just a perceptible kick into the 1 or 2 milliamps. 1, 2, 1, 2, 1, 2. That's grand, and that's nice and low. Right, we go up another setting. Okay, we're up. Right, just key, talking away from the mic, and now we're going to go. Okay, screen current's going up a bit high. That might need a bit more tuning when that occurs. That's a left-hand meter. 1, 2, 1, 2, test, 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 test. 1, 2, 1, 2. And we've got nearly 500 watts out. So on the peak. So we're going to be careful what we're doing here now. Let's just check grid current and make sure we got nothing too much there. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Test, 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 test. Audio, audio, audio. Testing, audio, audio. Great, no grid current perceptible. Going back to the screen current again. Audio, 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 audio. Now that might need a bit of tuning because my anode current is still appreciably low, but my screen current is approaching 20 milliamps. Audio, 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 audio. And we're getting a good old power. So we're at full UK legal limit here. We're over 400 watts on the other side. I'll just swing the camera around in a minute, but I think that's pretty much okay. Now it reads in the manual that this amplifier can go higher than the current power I'm putting through there, but I'm not getting good peaks, so the peaks could be a little bit higher. I'm not sure whether this mic gain is really helping much here on this rig, but let's just check. We're still, I've held the key down all this time, so let's go audio, audio, audio. That looks pretty good. Audio, audio, and we're getting good signal. Audio, audio on the other side. So I'll swing this around. Okay, I've keyed off, and okay, I'm just going to go to the setting for output on here. High voltage is still good. Okay, that thing. Okay, testing, testing. Audio, 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 audio. 1, 2, 1, 2, 1, 2. Peak, peak, peak. Test, test, test. 1, 2, 3, 4. 1, 2, 3, 4. I suspect that I've got the attenuator on a little bit too high. 1, 2, 3, 1, 2, 3. I'm quite pleased with that. I think that's a pretty good level of amplification. It I think I need to tune it a little bit. I'll try the CW position again, and but the trouble is that I don't like putting a constant carrier wave on while I'm tuning. I'll have to do it very quickly, and there's a bit of an SWR between the transceiver and the amplifier when I go to CW mode for some reason, although we're not detecting hardly any SWR on the, well, 1.6, 1.7 ish on the normal speech pattern through SSB. The linear's got very small reflected because it's going into the dummy load, but this is the transceiver's output's going into the amplifier, and I'm keeping it going like this. It's fairly constant. I think this is pretty good. I'm looking at the power output down there. That's nice and steady. The current's not rising on the anode current, and neither are the other currents. Everything looks fairly stable. Okay, let's key off and come back over here. Right, that's I'm just keying that up while I'm talking on the camera, just to make sure that everything else is fairly good. We're doing peak power at the moment on here. I've just switched this across. Okay, grid 1, grid 1, grid 1, grid 1, no current discernible there. Grid 2, this is a screen. 1, 2, 1, 2, audio, 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 audio. Okay, that's getting quite high. Audio. But I'm hardly going to talk like that when I'm on SSB, so we have pretty much got a stable linear, I think. The idea is to don't exceed 25 milliamps on the screen current, and we're getting quite close to that, and generally it's indicative of the tune not being tuned very well. And you need to tune for minimum current on the anode, and the load you tune for maximum power. You can see a dip when you do the load on the anode as well, so some people do a dip on both sides of the anode current, but on power out I'm quite pleased with that so far. I think it could do with a bit more tuning. What I need to create is not a CW noise generator. I need a tuning signal to be modulated so that is stable at a constant setting, so that I can get this linear work tuned better, and that goes across all my other rigs. Modifications to do now. You'll notice that there's about 5/16 of an inch down here, a gap between the tabletop and the bottom of the linear. When it's got the cover on, that seals the whole top cover, and the air intake's underneath below the high voltage transformer. So the blower fan has to draw air all through all these components and then back into the top there, which is quite close to the lid, and into the chamber here, and the RF box. That's quite a torturous route, and I don't think, oh, it's gone cold now, the air, that's good. That's not a great cooling configuration, so I'm going to get bigger feet to raise this up about 3/4 of an inch, 20 millimeters, so we've got a good lot of air underneath to be drawn in underneath. You could make holes in the top, but I'm not going to do that, for the simple reason being that the idea of inducting the cooling air goes over the components. The small transformer gets quite hot. I imagine the big transformer will get quite hot after prolonged usage, but I haven't tested that yet. So there you have it. That's a Dressler D-200S, which is fully working, and with an unknown valve in there, or unknown condition, the second-hand valve. The question is it worth getting a new 4CX350a? But if anyone's got a manual, a service manual for this amplifier, I'd be very keen to hear from you. Please let me know, because I think there's some setting up to be done. Say in its manual, when I read the manual, let's have a look. It's got some rather outrageous, and this is from Dressler. It's got here power levels. Right, consideration on power levels. The following scheme gives an idea of what maximum power outputs can be achieved and what reasonable output power levels should be made with this model. So for the 4CX350 alpha, reasonable output in FM is between 200 and 300 watts, and reasonable output in SSB is between 400 to 700 watts. Maximum output, that's with the switch at the back, switch the high position, or is it the low position? I can never remember. What's it say? Yep. With the switch at the back, switch the high position, which bypasses the attenuator, which is right at the very back there, the input. It says, you know, so we're going in direct, but you've got to watch your input wattage levels. Its maximum in FM is between 300 and 400 watts, and its maximum in SSB is 750 to a kilowatt. Yeah. So there we go. There's the amplifier working. I don't know if I can add any more to this, so I think we should draw a line under that one, and that's it. A nice case, superb. And those dull backlights on the meters, which I complained about earlier, certainly look nice and bright enough when it's dark. There is another light, by the way, that top, you might see a little LED lurking under the top right hand side above the 500 milliamp on the scale. That's the overload light. Anyway, the linear is still running. I think we'll switch it off and put that back on the shelf until we need it again. Sorry about the focus, I'm losing focus. Why are we losing focus? There we go. Let's just throttle out a bit, there we go. That's it. Right, thanks very much. Stay safe during the lockdown, and I'm going to go through my HF Linear next. It's going to take me a day to be able to get this uploaded on my very bad internet speeds. Okay. Cheers for now. Bye bye. Stay safe, everyone.